As we begin looking at this video in section 8.4, before we work through some homework problems, I would like to make some observations. This section is on polar graphing, polar plots, and when we describe a point in the polar coordinate system, it has two components, a radius and a direction. So if we were to reference, let's suppose, this point here, let's suppose that every green line is 1 unit from the center, then every point on this circle is 1 unit from the center. These points are 2 units, 3 units, and etc. So this point has a radius of 1, 2, 3, 4, 5, 6, 7, and it is in a direction of 60 degrees. But unlike rectangular coordinates, that's not the only way to describe that location. We could describe it also using radians instead of degrees, so we could call our angle pi over 3. There are also an infinitesimal number of angles that are coterminal with 60 degrees. So anything that's coterminal with 60 degrees would give us an equivalent point. For example, if we add 360 to that, we're in the same location. So 7, 420 is at the same exact point. If we go in this direction, this many units, we'll end up at that particular point. We can also go in the negative direction. If we subtract 360 from that, then 7 negative 300 degrees is also a point that is in that same location. So all of these are at that same location. We could have positive angles, negative angles. We could also describe it with a negative radius. You might say, well, how would we do that? So if our radius was negative, it would be -7. It would be the same magnitude if it's going to be that far from the center. But how do we do a negative radius? Well, let's suppose that our angle is in this direction. Suppose our angle is 240. Then if we go 1 unit, we would be here. If we go 3 units, we would be here. 4 units or 5 units here. If we go no units, we would be there. So in the direction of 240, if we start here and count positive numbers, we go towards 240. But what if we count negative numbers? Well, negative numbers would go away from 240. So if we go away from 240, 1, 2, 3, 4, 5, 6, 7 units, we would get to that same point. So if we use the angle 240 degrees, or it could be its radian equivalent, and go away from that angle 7 units, then we would get to there. So all of those are ways of describing that one point, which that's both good and bad. It can create issues if we're doing things like finding intersections of two equations, because when we do things like substitution or the addition method, we're using the assumption that when two functions intersect, that the name of that point is the same for both functions. But if for one function it uses that name for that point, and for another function it uses that name or even that name for that point, then as far as our radii being equal or our angle being equal, they're not. And remember, that's what substitution uses, is the fact that when we're doing x and y, the excuse me, the x coordinates are exactly the same and the y coordinates are exactly the same at a point of intersection. But for these 2 points, the radii are not the same and the angles are not the same at that same point, so that complicates the issue of finding points of intersection. But that's just kind of one thing that may not have been covered in the in the video for the section that I did want you to be aware of. So let's proceed and work several homework problems. So let's take a particular rectangular coordinate. Let's start doing that. So let's take a rectangular coordinate and convert it to polar coordinates. So let's do this one. The rectangular coordinates here are 3, 4. That's x and y. And let's convert that to polar coordinates. So without completely deriving the formula for you, we can use the formulas that the other video and the book give us. We need a radius and we need a direction. So the radius of that basically comes from the Pythagorean theorem. If we know the x and the y coordinates, then we can get the hypotenuse. So the hypotenuse squared is the x coordinate squared plus the y coordinate squared, or the radius is the square root of that. So the radius is the square root of 3 squared plus 4 squared. So the radius is the square root of 25, or 5. If we want that angle, tangent from that angle is opposite over adjacent, which is the y over the x. If we do inverse tangent of 4/3, inverse tangent, then that's about 53.1 degrees. So that's our angle. So the biggest thing here is just knowing the formulas, how to get the radius from the x and y coordinates and how to get the angle from the x and y coordinates. We have to be careful because when we do inverse tangent, we might get an answer, but it may not be in the correct direction. For example, if our point is, let's say our point is, I'll just do this one. Let's say that's our point. Then if we want the radius, the radius is the square root of the x component squared plus the y component squared. So 36 plus 4 is 40. 40 is 4 times 10, so the square root of 4 times the square root of 10, so that's our radius. And then to get our direction, tangent of theta is the y over the x. And that'll give us theta. But we have to be careful, because if we do -2 divided by -6, that comes out to be positive, and when we might type inverse tangent, we get 18.4. Well, notice 18.4 degrees is in the first quadrant. Our point is located in the third quadrant. So how are they related? Remember, they have the same reference angle. So our angle is 18.4 degrees past 180, so 198.4 degrees. Remember, the reference angle is always measured from horizontal. So this horizontal is 180. Go past it 18.4 and you get to 198.4. So that's converting from rectangular coordinates to polar coordinates. Now let's go from polar to rectangular. So let's suppose we have a point located here, or let's go here. The rectangular coordinates are 1, 2, in a direction of 30 degrees. And the formulas we use is that x is r times cosine theta, and y is r times sine theta. So if we know r and we know theta, we just plug those values in, and that gives us x and y. So x is 2 times cosine 30, which cosine 30 is root 3 over 2. So x is the square root of 3, and y is 2 times sine 30. Sine is 1/2. So that makes, or sine 30 is 1/2. So that makes y 1. So our ordered pair in terms of x and y is root 3, 1. So we've gone to the right, root 3, and we've gone up 1. So that's probably even easier. That's just entering directly into that formula. And as long as it's a standard angle, we can just use our unit circle to find out those values. Another exercise we have is converting equations from rectangular to polar or polar to rectangular. So let's go from rectangular to polar first. So if we have an equation like this is the equation of a line. So remember our formulas. X is r cosine theta. Y is r sine theta. R squared is x squared plus y squared. And tangent theta is y over x. So we just want to use these formulas to transform this equation from x and y to r and theta. So x is r cosine theta. Notice that takes that x out of the equation and puts r's and thetas in it. And y is r sine theta. So now our equation has r's and thetas in it. If we want to, we could factor an r out on the left side, and that would give us 3r times 3 cosine theta plus 5 sine theta. So that's an equivalent equation in rectangular coordinate or polar coordinates. Let's look at x squared plus y squared equals 25. So we could do this a couple ways. We could replace x with r cosine. That's squared. We could replace y with r sine. That's squared. Remember, when we have a product, we square each of those. So we square r and we square cosine. Now we're not squaring theta because theta is the input to the function we call cosine. So we're squaring the r and we're squaring cosine theta. So when we square cosine theta, we call that cosine squared. Same thing here. When we square this, we square r and we square sine theta. So we can either call that sine theta, all of that squared, or we can just write it as sine squared theta. On the left side, both terms have an r squared, so we can factor that out. And notice what's left in parentheses. In parentheses, we have an identity. Cosine squared plus sine squared is 1. So we're left with r squared times 1 equals 25, or if we take the square root of both sides, we get that r is plus or minus 5, or we could just say 5. So if you think about plotting an equation where the radius is 5, notice that equation doesn't have a theta in it. So that means no matter what direction we go a radius of 5. If we go in this direction, our radius is 5. This direction, our radius is 5. 5, 5. And what do we call a shape where every point is the same distance from the center? That's a circle. Mine looks more like an ellipse, but that's the equation of a circle. This is the equation of a circle in rectangular coordinates, centered at the origin. Remember, x squared plus y squared equals r squared. So this number over here, this is our radius squared. Our center of our circle is there. This is a much simpler equation. So sometimes our equations are simpler in polar coordinates, sometimes they're simpler in rectangular coordinates. If we go in the other direction, let's suppose we have 2r cosine theta minus 7r sine theta equals r, or let's say r squared. So anytime we have r cosine, we're going to replace that with x. Anytime we have r sine, we're going to replace that with y. And remember, r squared is x squared plus y squared. Which brings up something I meant to mention earlier. On this previous problem, we could have done it this way, or we could have said, well, x squared plus y squared is equivalent to r squared, so we could have changed the left to r squared, and we would have ended up the same place. So that's just an alternative way to have done that. But anytime we have r squared, we can replace it with x squared plus y squared. So now this equation is in rectangular coordinates instead of polar coordinates. But you might say, what if we don't have r's? What if we just have cosines and not, or sines, and not r cosines and r sines? So let's suppose that we have this one. So if we don't have an r with our cosine or a sine, we need one. So we're going to multiply the whole equation by r so that we have an r cosine here. So when we do that, the first term gets an r. So we can call that 4 times r times cosine. And the second term gets an r, so we can call that 5 times r times sine. And we also have to multiply the right side by r. So where we have r cosine, we just change that to x. And where we have r sine, we change that to y. And then where we have r, if r squared is x squared plus y squared, then r would just be the square root of that. So we change this side to the square root of x squared plus y squared. So that's taking that polar equation and changed it to rectangular coordinates.